In this video, we will solve a JEE Mains previous year question based on the binomial theorem. Let us carefully understand the problem and learn how to approach this type of question. This question was asked in January 2026 session. First, we observe the question carefully. So it is given that 1 plus x or 1000 plus x 1 plus x power 999 and so on x power 1000. So in question it is to find the sum of the coefficient of x power 499 and x power 500. So if we find individually each term the coefficient of x power 499 and x power 500 and sum it, it is very difficult to find the sum of these coefficients. So in this case we approach another method. If we see carefully the expression of this problem, it is given 1 plus x per 1000 plus x plus into 1 plus x to the power 99. So here 1 plus x to the power 1000 then decrease by 1, but x is involved, so it is multiplied by x, but 1 plus x divide and so on in this case. So in this case if we multiply x by 1 plus x by first term, this term by first term, then we will get second term x into 1 plus x to the power 999, and if we multiply this term by this term, then we will get third term x square 1 plus x to the power 998. So in this case we get an GP series whose first term a is 1 plus x power 1000 and common ratio r is equal to x by 1 plus x. So if we find the sum of the GP series, then we get the sum of this expression. So if we know the sum of the GP series, like we write a note here, suppose the GP series AR square up to AR power n minus 1. So A is the first term, AR the second term, AR square third term, and R is the common ratio. Then the sum GP series sum S is equal to A first term R to the power n minus 1 by R minus 1 if R is greater than 1. If R is less than 1, A R to the 1 minus R to the power n over 1 minus R if R is less than 1. So depend on R, the GP series sum divide it two terms. First term is if R greater than 1, then GP series sum is this. If R is less than 1, then GP series sum is this. So our case the R is this x over 1 plus x. This is strictly less than 1. So we apply this sum formula. S is equal to first term into 1 minus R power n over 1 minus R. So our problem is x power 1000 then x into 1 plus x power 999 up to x power 1000. Sorry, it is 1 plus x. So first thing, find the number of terms are involved in this expressions. First term power is 1000 and the last term is 1 plus x. It is not here, means it is 0. So we find the term, how many terms are involved. It is the easy formula to the first number is 1000 minus 0 plus 1. So it will be 1001. This is the number of terms. This is actually n. So this sum is equal to, suppose it is denoted by s, and the first term is 1 plus x power 1000. It is r is less than 1, so we apply this formula. 1 minus r is x upon 1 plus x, and n is 1001 over 1 minus r. R is x over 1 minus x. So now we simplify this term very carefully. 1 plus x power 1000, the LCM over here. 1 plus x power 1001 over 1 plus x power 1001 minus x power 1001, and this term is here 1 plus x minus x over 1 plus x. This term is cancelled. Now s is equal to 1 plus x power 100 x power 1001 minus x power 10, it is 1 plus x. So if we see 1 plus x power 1 plus x power 101, this term is here 1 plus x by 1, so 1 plus x by 1. So now that is 1 plus x, that is 1 plus x power 100, that will be get 1 power 1001, and this term is rest of are same. 1 plus 1001 minus x power 1001 over 1 plus x power 1001. So this term and this term are cancelled. So the final term will get 1 plus x power 1001 minus x power 1001. In the question, our actual we finding x power 499 and x power 500 coefficients. So sum will get x power 1001 minus x power 1001. So only term are involved x power 499 and x power 500. This term are only here. So we expand this term 1 plus x to the power 1001 in binomial expansion. So we will get 1 plus 1001 c1x plus 1001 c2 x square and so on. So we will find 1001 c499 x power 499 plus 1001 c500 x power 500 and so on. In last term is x power 1001. So only the coefficient we need this coefficient and this coefficient. So sum of this coefficient, sum of coefficient x power 499 and x power 500 is equal to 1001 c 499 plus 1001 c 500. So only we calculate this sum. Now we want to find this sum 1001 c 499 plus 1001 c 500. Remember one thing, in binomial theorem one identity as well is known as the Pascal identity. Pascal identity tells us, if we write its note, the Pascal identity is NCR minus 1 plus NCR is equal to N plus 1 CR. So it is n, left hand side is n is same, but r term is r minus 1 and r. Then it will be get nth term is increased by 1 and the bigger r is here. So in same identity is used here. Same 101 and 100 are same, nth values are same, but the r minus 1 tens term, that is r. So that will use the Pascal identity. This sum will get 1002 C 500. That is 1002 500. In the overall question, we use GP series, and this GP series sum is S is equal to A is 1 minus R power n over 1 minus R, because our R is less than 1. And then we find the sum of this GP series equation, that will get 1 plus x power 1001 minus x power 1001. Then we expand this term in binomial coefficients, that is 1 plus x 1001 c 1 up to in term minus x power 1001. This term is not used because we find the coefficient of x power 499 and x power 500. So only term are involved here. This sum, we get the coefficient sum, then we use the Pascal identity, then we will get the final answer is 1002 C 500. This is the answer, and option A is the correct answer.